Okay, question 3, projectiles 2022. Okay, so question 3A. Projected up to C from point. Okay, so it's projected at angle alpha. It's 14 right 3. So you'll hopefully get some nice consolation from that. And we have this guy 60 and minus 60. Okay, so simultaneous equations. So s of x is equal to 60 and s of y is equal to 60. Okay, so from that we'll be able to take time of flight. It's equal to ux time of flight, which is equal to u cos alpha tf. So which is equal to 14 root 3 cos alpha tf is equal to 60. So time of flight is equal to 60 over 14 root 3 cos alpha. Right, let's put a box around that fella. Nice results. Now sy is equal to uy time of flight minus half gt flight squared is equal to minus 60. So there'll be lots of nice calculation here. So u sine alpha by 60 over u cos alpha minus half g all this squared. So 14 squared by 3 by cos squared alpha is equal to minus 60. Okay, so these guys cancel. And you'll get rid of a 60 as well. And we get so a nice tan alpha minus 20g, well, divided by 2, so that's 10g over 14 squared. What's that? That's 14 squared. 56, 196. Okay, 196 cos squared alpha. Is that it? 10g, yeah? That should be it. So 20, 10g. Plus minus 1. Now, density 1 over cos squared alpha is equal to 1 plus tan squared alpha. So we get 10g over 196 plus 10g over 196 tan squared alpha minus tan alpha, and that's coming over as well, so it's minus 1 equals 0. Okay, so 10g is 98.1 over 196. Looks like there's going to be a nice cancellation there. Tan tan squared alpha minus tan alpha plus 98.196 minus 1 is equal to 0. Okay, this guy hopefully will cancel nicely. So what's that? 98.1 divided by 196.5. Okay. So it's 0.5. Tan squared alpha minus tan alpha plus half, so minus half is 0. Okay, double everything. You get tan squared alpha minus 2 tan alpha, it's looking good. Minus 1 equals 0. Okay, so maybe it isn't, or it is. What's that? Tan alpha minus 1. Tan alpha plus 1 won't work. Equals 0. That does not work out. Okay, so that gives me tan squared alpha minus 2 tan alpha, but it gives a plus 1. Okay, so unless there's some back-end error there, something up, I'm going to have to plow on the way it is, but then it doesn't give me 2 angles for alpha. Tan alpha equals 1. Okay, what will that look like? Well, that's 45, yeah. With 2 possible angles of alpha. Well, I'm guessing, yeah, okay, tan alpha is equal, and the times of flight. Okay, so time of flight, or t flight, we have up here in that, so it's 60 over 14√3. Cos alpha. So cos alpha now would be 1 over root 2. So that would be root 2 over 1. So time flight is equal to 60 over 14. 60 over 14 root 2 over 3 seconds. Okay, so there's some issue there that's not giving me an extra angle. Gonna have to have a look at that again later. That'll do for the moment. Okay, so part 2. Particle projectile plane using angle beta to the plane. Okay, so inclined plane. Plane is inclined at 30 degrees. It's angle beta there. Speed u. Plane is inclined at 30. Find the greatest range of the plane in terms of u. So R max as a function of u. So we'll be going something dr d beta probably, setting that to 0. Okay, well first of all let's find dr, or let's find r. Well, the range is equal to s of x when sy is 0. So sy is equal to uyt flight minus a half g t flight squared, and that's equal to 0. So uy is u sine beta t flight minus g over 2 t flight squared equals, oh jeez, g. U sine beta t flight minus not this g, it's half a y in the y direction, which is g cos 30. Let's do the 30 triangle. That's root 3, that's 1, that's a half. So cos of 30 is root 3. Root 3 over 2. TF squared is nothing. Okay, so either TF is equal to 0, which is the trivial case, or TF is equal to U, no, is equal to 4 U sine beta over G root 3. Is that right? That should be right. Let's just check. So that goes over there. That's 4. Yeah. Okay. Now range is equal to s of x, which is equal to ux t flight minus half g sine, so that's half again, so g over 2 tf squared, which is equal to u sine u cos beta by 4u sine beta over g root 3 minus g over 4 16 u squared sine squared beta over g squared 3. Okay. Is equal to 4u squared sine beta cos beta over g root 3. What's going to be under here? G 3g, so it's root 3 root 3. That is going to be 4. Nice bit of cancellation. 4u squared. 4u squared sine squared beta. Okay. Do I take out sine beta? Don't think so. Not yet. Okay, so range. Okay, I'm going to take out what's common. So 4u squared over g root 3 into sine beta cos beta minus sine squared beta over root 3. So we've got a root 3 hanging in there. I'm wondering if that is correct. Probably is. Okay. A half a t squared. The a is going to be the g sine 30, which is a half. Okay, so it's a g over 2, so g over 4. It's the time squared, so it's it's 2 root 3's. There's no cancellation there. 16 u squared sine squared beta. Yeah, okay, seems okay. Okay, in terms of u. Okay, so now d alpha. No, d beta. So basically, the only thing range is dependent on is beta. So we have to differentiate with respect to that. So let's have a look at that. Okay, so it's equal to that factor there, which is grand. Now, chain rule the first by the differential of the second plus the second by the differential of the first. Right, so that's that one. And this guy is twice sine beta by the differential of sine beta, so that's cos beta over root 3. Okay, right. So it's equal to that. And the reason I'm not worrying about that factor is because I know when I'm setting that to 0, that's not going to count anyway. So that is cos squared beta, that bit, minus sine squared beta, minus 2 over root 3 sine beta cos beta. Now, to maximize, the only variable is beta, so we're going to set that equal to nothing, and we get it. So straight away, that factor doesn't matter. So it'll be cos squared beta. It's going to be all of that equals 0. So straight away, we can cancel what? We can remove a cos beta, I suppose. Okay. Not really. Okay, we can substitute that cos beta minus 1 plus cos squared beta. So just transferring that. Minus 2 over root 3. Okay, this guy, sine beta, cos beta, all equals 0. Okay, so that's 2 cos squared beta minus 1 minus 2 over root 3 sine beta cos beta equals nothing. Okay, so keep on going. Okay, so so 2 cos squared beta minus 2 over root 3 sine beta cos beta is equal to 1. Okay, let's divide by cos squared beta. So we get 2 minus 2 over root 3 divided by cos, so tan beta is equal to 2 over cos squared beta, which is 1, and that's 1 plus tan squared beta. So we hopefully get a quadratic. So that's equal to 2 plus 2 tan squared beta equals all that up there. So 2 tan squared beta plus 2 over root 3 tan beta is equal to, they cancel, yeah? Is equal to nothing. Okay. So tan beta is nothing, or tan beta is equal to minus 2 over root of that. So tan beta is equal to minus 1 over root 3. So beta 1 over root 3, what's that? That's 3 plus 1, that's 2. So it looks like 30 degrees. Or if beta is 0, tan beta, yeah. So, yeah, the trivial result, so that's 30 degrees. So basically it's being the same angle as the inclined. Slow. Okay, so the maximum range then, or max, is equal to whatever our expression was for r, which is this guy, with beta equals 30 degrees. So r max is equal to 4u squared over g root 3 yeah, into that one. So sine 30 cos 30 minus sine squared 30 over root 3. Okay, bit complicated there, but let's keep going there. 30, yeah, we have that triangle up there, so it's equal to 4u squared over g root 3. Sine is a half, cos is root 3 over 2 minus sine squared 30, so a half squared, so 1 over 4 root 3. Okay, so if we take out 1 over root 3 there, will that work? Yeah, so that would be 4u squared over 3g what's left there? 3 quarters minus 1 quarter. Is that right? Yeah. Which is equal to, looks suspiciously nice. So that's 2 quarters, that's a half. So 2u squared over 3g. That looks like a nice even result. But wouldn't be surprised if there's some error there, but that's looks okay so far. Okay, so that would mean r max is 2u squared over 3g with an angle of 30 degrees projecting.